Hello everyone. Today we are going to solve few questions from Codeforces Global Round 14. And the first question we are going to solve is the Phoenix and Gold. So in this question, we are basically given an integer n and an array w with n distinct integers, which represents the weight of these distinct integers represent weight of n pieces of gold. So essentially, so in this question, our task is to so basically there's this phoenix in the question who is supposed to put this n distinct gold, all the n distinct gold pieces on a weighing scale such that it never attains a particular sum x, because if it does then the weighing scale will explode. So we have to determine whether such a rearrangement is possible. In more general term, we basically have to rearrange the given array w uh, such a summation from j equals to 1 j equal to 1 sum for each I, for any I, uh, rather summation of any prefix of the array is not equal summation of any prefix of the array is not equal to x. So for any I, summation is just a summation of the first I elements is not equal to x. So how are you going to approach this question? So first thing we know is that there are n distinct objects and distinct weights, sorry, not objects, and distinct weights. And so what we'll do, we'll first of all uh, okay, wait a minute. Yeah, so basically we'll sort the given array, and after sorting the array, basically our objective is to print the rearrangement of that print basically we have to print the rearrangement of the array. So after sorting the array, we'll have n distinct elements sorted from in ascending order, and distinct elements. So what we'll do, I will make the prefix sum array of this array. So I will get a prefix sum array of this array. And now what we are going to do is, so for example, if at any stage I income, so if the number x does not exist in the prefix sum array, so we can directly go ahead and write our answer yes and print this array. But what if x exists in this array, x exists in this array? So basically this will imply that the sum of a particular prefix in our rearrangement has x as its sum, and we cannot go with this arrangement. So in this case, basically what we'll do, suppose the summation of first I element is equal to x. So what we will do, we'll basically exchange the ith element and the last element. So this since both of them are going to be distinct, it will ensure that summation summation I minus 1, a summation of plus first I minus number plus ith element is equal to x. We know that. So basically if I exchange these two number, then the summation of the prefix will be summation I minus 1 plus a is last element, and this must be strictly greater than x. So essentially we are never going to encounter x if we make this if we make this swap. So basically we will be taking care of the condition. Now we'll have to look in the condition where we have to essentially print no. No, printing no implies that there does not exist any that there doesn't so for example, if summation of a w array is equal to x, so our objective is to place all the n pieces. But if our summation itself is equal to x, eventually after placing all the blocks, will the weighing scale will explode. So So we just have a check, if statement in the beginning. If sum of all elements of W is equal to X, print no. Else we'll go back to this testing with whether that will sort the element and look into the prefix sum and exchange whatever is necessary. So basically this inequality is the proof of our correctness. So the code is pretty simple. Take a input, take n as input, sort W, then check for the summation of W, and if it is equal to X, print straight away, print no. Else else uh, you will have to print yes, but you just have to take care of this rearrangement thing which I explained previously. Okay, so now we'll go to the second question. So the second question is Phoenix and puzzle. Phoenix and puzzle. So in this question, basically we are given an eq- an right isosceles angle triangle, and our objective is to check whether we can make a square using all these and triangle such that there are no holes and no overlaps. No holes, no overlaps. So the question is hinted into the example test case. So in the example test case, they have shown that when n is equal to 2, the we can make a square in this form, and when n is equal to 4, we can make a square in this form. So basically these two examples are the base cases of the base cases are the base cases. Let me show you how. So essentially this in these two cases there is no further subdivision possible. So basically if I multiply 2 with any square number, for example 4, so I can basically replicate this structure something like this. So when I'm given 8 triangles, I can convert it into this. Similarly, when I multiply 4 with 4, I will get 16, and I can write 60 make a square out of 16 elements like this. Okay, so I have used all the 16 triangles to make a square. So basically we'll have to check that whether a given n divided by 2 is a square number, or n divided by 4 is a square number. Obviously we'll have to check for the divisibility by n is equal to n is equal to 4 for this question. So if this is done, we are good to go. Hmm. Yeah, so basically the code for this question is very simple. We'll just check if n mod 2 is equal to 0, and if n divided by 2 is a square number. So this is the condition for checking the square number. I wrote this code in Python. And similarly we'll check if it is divisible by 4, and the same condition is applicable. Sorry, star and divided by 1 is equal. Okay, so this is the basically the code of the question, and we'll print yes if any of these two if conditions are true, else we'll print no. So this was a pretty straightforward and simple question. We'll move on to the next question. This is where is it? uh this is a phoenix and tower. So now the third question is phoenix and tower. Oh, sorry, phoenix and tower. So in this question we are given an, let me open it. Mm, yeah. So in this question we are given three integers n comma m comma x, and we are given an array h which represent heights of h blocks, height of n blocks, h1 h2 all up to hn. So in this question, and we are also given this condition that the height of the maximum highest block in H is at most equal to x. This is the condition. So basically this H represents the height of the okay this represents the height of the array. Height of the This height array represents the height of the boxes uh, we are given, and our task is to make m towers out of these boxes, such that uh, no two boxes have the height difference greater than x, and strictly greater than x, as it is mentioned in the question. Now the question is, how are we going to approach this question? So I thought over it, and what the solution says is, we'll sort the height array. We'll sort the height array. So once we have sorted height array, what we'll do? So basically, we'll have m towers to make. So initially, the height of all the m towers will be 0. So now what we are going to do is, uh, take the first element and place it in the first position. Take the second element and place it in the second position. Take the mth element and place it in the m position, likewise. And take the m plus 1th element and start placing it in the first position itself. Now I will have to show you how is placing like this not ensuring that that absolute sorry the max of any height in m, max of m minus min of m, is less than equal to x. Okay, so for suppose at this position, uh, after I go through one round of placing, I come back, and suppose there is already a element existing over here. Suppose I call it hi. I call this element of hi plus 1, and I am placing over here m plus ith element over here. So for any prefix of size h of m plus I, uh, h of m plus I will be the largest element which I have placed till now. The last element which I placed is the largest element I have placed till now. So basically I have to prove that h of m plus I plus h of I minus h of I plus 1, this thing is less than equal to x. So how I am going to prove this? So basically we know that hi is strictly less than equal to hi plus 1, and we also know that any element in hi is also less than equal to x. So any arbitrary element, so will h of I plus 1. When we add these two equations, we get hi plus m plus hi minus hi plus 1 is less than equal to x. So this proves, so basically this is the proof of our correctness, that arranging in this manner will essentially uh, satisfy our condition that there don't exist any two towers with a height difference as x. Now to look at the code, basically what we'll do, take n comma m comma x as input. uh, Basically we have to print that where ith box is going to which particular ith box is going to which particular tower out of the m tower. So basically we'll sort, and after sorting, whichever is the first block after sorting, it will go to the first tower out of the m tower. And basically ith tower will go to I mod m, ith block will go to I mod mth tower. So yeah, this is basically the explanation for problem 3. That's it for today.